Hi Intermediate, we're still on 4.5. Now what I'm going to do is a domain of an equation. What that's asking is what x values are allowed in the equation, okay? So it would be like what ages are allowed in a grocery store. So the domain of a grocery store is you can be any age, there's no restriction. And then we might ask, well, what's the domain for age for a well, I have to say there is a restriction in the first one. Nobody's going to be like negative, right? So you have to be like a positive number, but you get the general gist. Like in terms of ages, which are usually greater than 0, those can go in the grocery store. Wow, that can get complicated fast. Okay, and then like if you have a bar, if you try to go to a bar in the United States, you have to be 21 or older. So that's like a restriction. So when you're trying to figure out a domain of an equation, sometimes there's a restriction and sometimes there's not. So this is the best way I've learned to be able to describe this. The answer is all real numbers, or anybody can go in, like a grocery store. The answer is going to be all real numbers unless you have a fraction. If you have a fraction, you cannot divide by 0, right? Because then that's going to be undefined. Or if you have a radical with an even index, that right here, like if it's a square root, like something that's a square root or a fourth root or like a sixth root, that's what I mean by an even index. It's also called a root. If you have a radical with an even index, what's underneath here, which is called the radicand, then the radicand has to be greater than or equal to 0. Now, we're not actually going to hit this topic till late. We're hitting domain in this section, but we're going to not hit the radical, I think, till chapter 8. But I'm just going to teach it now because it's one of the more like, it's just abstract, which makes it difficult. So you're going to sort of get it taught twice. So I'm going to teach it now and then and later again. So the two cases you want to think of that have problems: if you have a fraction, the variables in the denominator can't divide by 0. If you have a radical with an even index, you have to restrict what's under here. The radicand, you have to restrict it to being greater than or equal to 0. All right, so here's some questions, and we're going to find the domain. Now, this is how your brain thinks about it. Like for the first one, there's no fraction and there's no radical, so there's no problem. This is like the grocery store. So the domain of this is going to be all real numbers. Now, I'm not going to be picky how you write that. You could say negative infinity to infinity. You could use the fancy R, however you want to do that. But basically, like anything can go in there. Any number you can think of can go in there. All right, now here you have a fraction, and you can't divide by 0. Like, for instance, you can't do 2 over 0. So that means that x cannot be 0. So you can write it like that. I'm just going to write it a couple ways that you just decide what you guys want. So x cannot be 0 for the domain. It can be everything else. So some people will write it in words. They'll say all real numbers except 0. Some people will write it out like on the test. They'll say, okay, it's everybody except 0. If you're doing interval notation, it's a little bit fancy, but it's really nice if you can do that. So you're basically saying you can take anybody on the number line but 0. So if you're doing interval notation, you have to watch how you write it. You're going to take the left side, don't include 0. So notice I'm writing open right there. And then the right side. Again, open on the parenthesis. Because what happens for interval notation, it splits the graph into 2 segments, this side and this side. And you have to write a solution for each side for the domain. So some people will write the domain like this. And this just says that you're excluding 0. Okay, for this one, if you let x be 5, you get 8 over 0, and that's the same problem. You can't divide by 0, which means that 5 is bad. You can't let x be 5. By the way, it doesn't matter. We're not worried about the numerator. It's you can't let the denominator go to 0. Okay, so for this one, the domain, x can't be 5 because that's going to make it go to 0. Okay, so you can write it out in words, and again, what I said before, this is really nice if you do this. But you got to just watch. It's going to split it into 2 segments. So it's this one and then U5 to infinity. All right, now for the radical, these are even indexes. So what I'm saying when I talk about the radical is, if you can remember, in the real system, not the complex, in the real system, we would say there was no solution to the square root of -4. In the complex system, we would say it's 2i. So the trick here is to remember that we're actually in the real system, not the complex. So that means that you can't actually put a negative under here. And just in case, I'm not sure if you guys all know this, you can actually do the 0. Square root of 0 is 0, just so you know that. Some people don't know that, so I always stress that. So that means what's under here, and we said the rule, it's over here, has to be greater than or equal to 0. So the domain for this guy is what's under here. I know this is really an abstract section, just do your best, okay? That's all anybody can do. So what's under here has to be greater than or equal to 0. If you're going to write it in interval notation, it's 0 to infinity. Okay, the next one, again, it's an even index. So what's under here, and this one's a little more work, what's under here has to be greater than or equal to 0. Now this one you have to actually solve for x, because there's more than one thing under here. So you move the 2 over. So what's under here will stay 0 or higher if you pick a number that's -2 or higher. I'm just going to say that again. That's a little hard to understand. What's under here will in total stay to be 0 or higher if what's put in for x is -2 or higher. All right, I'm going to just write it in notation, interval notation, for those who want it. All right, now a cube root's a different story, because in the real system, you could, for instance, take the cube root of 8, and that would equal to 2. In the real system, you could take the cube root of -8, which is -2. So in the real system, if it's odd, we can use the negative, because an odd amount of negatives will come out as a negative, so we're good. So for the odd root or the odd index, you can actually have positives and negatives underneath. So because this is odd, that means I can have positives or negatives underneath. So the domain for an odd index is always all real numbers, which again you could just write as -infinity to infinity. I know that is a super difficult concept. Since we haven't done radicals, I may make this bottom part for now extra credit on your test, but this part up here would be in the test. Okay, but I may tag this on just because if you made the effort to try to understand it, I may tag that on the end of your first test. But we're going to see this officially in like chapter 8, this bottom part. Okay, I know that's real tough. I do like that you can rewatch the video to get more clarity on it. You know, sometimes you just got to sleep on it and watch again. This video is like 9 minutes. You could just torture yourself tomorrow again for another 9 minutes and try it again if it was too much. Okay? Every now and then you get a topic that's very challenging, and this is it. And sometimes you just got to roll with it. Okay, gang, I'm not going to make this video much longer, so I'll cut off here and I'll start a new video for... We're still in 4-5 hanging out for more topics in 4-5. Catch you. Bye-bye.